Hello children, so welcome to aimsindia's online classes. Today from physics subject, motion topic we are going to continue. I think every one of you is familiar with the story of Apple and Newton. Sir Isaac Newton. Sir Isaac Newton. So one day he was sitting under the tree. So suddenly one apple fall on his tree. So then he began thinking. So why the apple is falling down? Means there must be something. There must be something which is attracting the apple towards the ground. So that's why it is falling. So he named that force as gravitational force. Gravitational force. So from that, one new law he proposed, which is called Newton's universal law of gravitation. Universal law of gravitation means in the universe all objects attract one another. All objects attract one another. So here, because Earth is a huge body, it's a very large body, that's why we can observe its attraction power. Whereas suppose you and your friend, you are standing side by side, but this attraction force we cannot observe. Why? Means the force is negligible. The force between two human beings is negligible compared to the force between one object and Earth. So according to Newton's universal law of gravitation, all the objects in the universe, they attract each other. They attract each other. If the attraction is by heavenly bodies, means huge bodies like Earth, we can observe that attraction. For normal bodies, we cannot observe the attraction. But we should not say there is no attraction. There is attraction force, but it is negligible. It is not considerable. Okay. So in this way, Newton proposed so that Earth will have gravitational force, or we can call it as gravity. We can call it as gravity. We can call it as gravity. Okay. We can call it as gravity. Next. So, because of that gravity, what happens? So, if there is any, if you suppose this is a leaning tower of Pisa, children. It is in Italy, leaning tower of Pisa. So somewhat the tower is somewhat slant. So let's imagine we have one minute, children. So let's imagine one elephant and one feather, one object, elephant, which is having more weight, and feather, feather. Somebody call it feather. If we drop the elephant and the feather from same place, from the top of Leaning Tower of Pisa, so what we will observe? Both of them, they will fall to the ground at the same time, irrespective of their weight. Irrespective of their weight. In this, we have to assume there is no air resistance. There is no air resistance. Means air is not stopping them. Suppose If air resistance is there, this feather is having very light weight, so that's why it will turn right side, left side, turn right, left, down, right, left, down, like that it will fall down. So that's why we have to assume there is no air resistance. There is no air resistance. In the absence of air resistance, both the objects fall to the ground at the same time. So why they are falling? Because of gravity of the earth. Because of gravity of the earth. So the earth, it tries to attract. So whenever it tries to attract any object, like larger stone or smaller stone, because of its attraction, there will be some change in the velocity of the stone while they are falling down. While they are falling down, their velocity increases. Their velocity increases or their velocity changes, which is called acceleration. Which is called acceleration because of gravity. Acceleration due to gravity we can call. Acceleration due to gravity will be created in the larger stone and smaller stone or elephant feather. In both of them, acceleration due to gravity will be created. So their velocity will increase. And they start falling towards the ground. But the question is, so why they are falling at the same time? Why they are falling at the same time? Because here the elephant is will be having more mass. Mass of elephant may be capital M. Mass of feather may be small m. What is mass? The actual matter present in the object, or the number of atoms or molecules present in elephant are more, capital M. In feather are less, small m. Both the masses are different, but still they are falling to the ground at the same time. Because of mass, the gravitational force also different. The gravitational force also, force acting on elephant is different. Force acting on mass is different. Because for attracting elephant, because it is having more mass, or for attracting stone, larger stone, because it is having more mass, we have to apply more force. For attracting larger stone, Earth has to apply less force. But still, why they are falling to the ground at the same time in the absence of air resistance? Because it depends on force by mass ratio. Force by mass ratio of larger stone. Force by mass ratio of smaller stone. This larger stone, force is F1, mass is M1. More force, more mass. Less force, less mass. Though forces are different, though masses are different, but this F by M ratio is always same. So that's why in the absence of air resistance, they will fall to the ground at the same time. They will fall to the ground at the same time, and same acceleration due to gravity created in both of them, which is equal to 9.8 meter per second square on the earth. Meter per second square on the earth. So here children, acceleration due to gravity means the uniform acceleration of a freely falling body like elephant, feather, larger stone, smaller stone towards the center of the earth due to earth gravitational force is called acceleration due to gravity. Means because of earth's gravitational force in a freely falling body, acceleration will be created, which is uniform, which is constant, which is always equal to 9.8 meter per second square, which does not changes. It may be larger object, it may be smaller object, it does not changes. So that's why we are telling that it is uniform acceleration. So that uniform acceleration which acts towards the center of Earth, means which is having direction towards center of Earth, or which is a vector, is called acceleration due to gravity. It is denoted by the symbol small g. Denoted by the symbol small g. Its value is constant for all bodies at a given place. Suppose from Earth, if we go to Moon, then it may change. For Earth, different value of g. For Moon, different value of g. Might be possible. But on the Earth, it is same. On the Earth, for a certain place, or suppose at equator, it will be same. At poles, it will be same. Like that. At a given place, it will be constant. So it is independent of size of the body, shape of the body, material with what the body is made, or constitution, whether it is hollow body or solid body. Hollow means inside the body there will be nothing. Solid body means, hollow ball means it's like a tennis ball. It's like a tennis ball. In the middle there will be nothing. Solid means it's like a cork ball. It's like a cork ball. Inside also it is filled with material. So okay, hollow material, solid material, or nature of the body. This G value does not depend on any of these values. Any of these values. If air resistance is ignored, if the frictional force because of air, stopping force because of air is ignored, all the bodies, light as feather or heavy as metal sphere or elephant, which are dropped simultaneously, means from the same point, from same height, hit the floor at the same time, because all bodies on the Earth will have same acceleration due to gravity, same value of z, irrespective of their size, shape, material, constitution, nature. Okay. So that's why both of them, both elephant and feather, fall onto the Earth at the same time. Next. Here. So true or false? Let's try to understand these sentences, children. The elephant and the feather each have same force of gravity. Is it true or false? They are having same acceleration due to gravity. But force of gravity is not same. It is false. It is false. Because elephant, force of gravity is more. Mass is more. Feather, force of gravity is less. Mass is less. But ratio is same. So that's why they will have same force of gravity. False. Elephant has more mass. Yet they experience same force of gravity. False. Elephant experiences greater force of gravity, yet both elephant and feather have same mass. Wrong. Mass is different. Force of gravity is different. On Earth, all objects, elephant or feather, have the same force of gravity. Wrong. Force of gravity for different masses, different force of gravity. Elephant weighs more than feather, yet they each have same mass. Wrong. Masses are different. Weights are different. Weight is nothing but force of gravity. It is also different. False. The elephant clearly has more mass, yet they weigh the same. Weights are same. Wrong. The elephant clearly has more mass, yet amount of gravity is same. Wrong. Elephant has greatest acceleration. Amount of gravity same. Wrong. See, all the statements are false only here. So, in vacuum, in air and in vacuum, if you drop one hammer and one feather, in air, hammer will reach the ground first, and the feather will reach the ground somewhat late, because they are in the air. This air will push the feather because of its light weight, towards right side, left side, right side, left side, down side, right side, left side. So that's why it is landing somewhat late comparing to this hammer. Whereas in vacuum, means when there is no air, both of them reaches to the earth at the same time. So, okay, actually in vacuum, both of them, they won't fall onto the earth. Actually, they will fly in the space, empty space. Actually, this is in the absence of air. Instead of vacuum, you can take it as in absence of air. In absence of air, both of them fall down to the earth at the same time. In vacuum, they will fly. They won't fall to the ground. They will fly in the empty space. So this acceleration due to gravity, G value changes from place to place on the surface of Earth. But at a given place, for all objects, it will be same. Because at equator, its value is different. At poles, its value is different. Its value is maximum at poles, which is equal to 9.83 meter per second square. Minimum at equator, which is equal to 9.78 meter per second square. So we can take average value, because the maximum value, minimum value, we can take average value on the Earth's surface anywhere as 9.8 meter per second square. Okay. So, but on the moon, it is 6 times less than that of Earth, only 1.61 meter per second square. On the moon, the gravitational force strength is 6 times less than the strength that on Earth. But whereas on the sun, it is 3 times more than that of Earth. 3 times more than that of Earth. So G value on the Earth is 9.8 meter per second square. On the moon is 1.67. On the sun is 27.4. Okay. So that's why because Earth, this is Earth size, this is moon size, the sizes are different. So that's why the gravitational force on the Earth is different from gravitational force on the moon. So that's why for this astronaut, mass of astronaut 120 kg on both Earth and moon. Earth and moon, the mass does not changes, because mass is the actual matter present in the body, so which is made up of atoms and molecules. That atoms and molecules for this astronaut on Earth or on moon same, but the Earth gravitational force is 6 times greater than gravitational force of moon. So gravitational force of Earth is 6 times more than gravitational force on moon. Because on the Earth, the gravitational force is, field strength is 10 Newton per kg. 10 Newton per kg. But here what? It's very, very less. Approximately 1.67 Newton per kg. 1.67 Newton per kg. So that's why, suppose mass 120 kg is there. If you need weight, we have to multiply. Weight formula is mg, mass into acceleration due to gravity, or it is also called as gravitational field strength. So weight on Earth. So weight on Earth equal to mass on Earth 120 kg into gravitational field strength 10. So that's why 1200 newtons. Here weight on moon 120 into 1.67, approximately 200 newtons, or 6 times. Earth is 1200, On moon how much? 6 times. By 6 we have to divide. 200 newtons. On the sun how much? To the earth value 3 times we have to multiply. 3600 newtons. So like that, on the earth and on the moon, masses are same, but weights are different. Gravitational field strengths are different. Acceleration due to gravity values are different. So the acceleration due to gravity always directed towards center of earth. So it is a vector. So that's why it is a vector. Whether the body is projected upwards or freely falling downwards, but always points towards the center of the earth. It is a vector. So if a body is falling downwards, earth is also attracting downwards, body is also falling downwards. So in this case, the velocity will increase and the acceleration due to gravity will be positive. G value will be positive. Whereas if a body is projected upwards, body is trying to go up, but earth is trying to pull it down. So in this case, velocity of the body will decrease and acceleration G value will be negative. So at the center of the earth, the acceleration due to gravity is always 0. Okay, children. So next. So we have equations like V equal to U plus AT, S equal to UT plus half AT square, or V square minus U square equal to 2AS. Like this, we have 3 equations of motion for uniformly accelerated bodies. Means for bodies moving with constant acceleration. For that kind of bodies, this equations of motion, 3 equations of motion are there. So now we are applying the 3 equations of motion for freely falling body. So motion of all dropped bodies falling towards earth when there is no air resistance, or if air resistance is ignored, is known as free fall. So bodies falling towards earth without air resistance is called free fall. So for a freely falling body, because in the name itself we are telling it is falling freely without any force, means initially the velocity will be 0 and it is falling downwards. So acceleration due to gravity will be positive. So for a freely falling body, so U equal to 0, A equal to plus Z. So we have the equation V equal to U plus AT. In that, if we replace the values, V equal to U plus, in the place of A, we can keep Z, because this is for normal acceleration. If you apply for earth, then normal acceleration will become acceleration due to gravity. V equal to U plus ZT, that formula is coming. But here U value is 0. So V equal to ZT we can write. This is the equation for freely falling body. One equation of motion for freely falling body. So we have V equal to U plus AT. In the place of U we can keep 0. In the place of A we can keep ZT. So this is first equation of motion for freely falling body. This second equation of motion, U place 0, 0 into T 0, half A place we can keep Z. So S equal to half GT square. This is second equation of motion. V square minus U square equal to 2AS. This U square, if you keep 0, it will become 0. V square equal to, in the place of A we can keep 2GS. Or Sn equal to U plus A into N minus half. U 0. A, in the place of A we will keep Z. Z into N minus half. So these are the equations of motion for freely falling body. Freely falling body. What is the use of this equation? It is used to find either V or G or T. If any two quantities are given, we can use this formula and we can find the unknown quantity. This equation is used to find final velocity after touching the earth. While touching the earth, what is the velocity? For finding that, we have to use this equation. This equation, S for displacement, before touching earth, how much distance it has traveled. If you want to calculate, we can use this formula. This formula also, velocity after reaching earth. So this is distance, Sn, means here 0 to 1 second, 2 seconds, 3 seconds, 4 seconds. Like that, from 2 to 3. In that 1 second, what is the distance? Distance in one particular time. If you want to find, we can make use of this equation. Okay. So for a freely falling body, the ratio of distances traveled in 1 second, 2 seconds, 3 seconds, 4 seconds are 1:4:9:16. Because S equal to half gt square they have given. 1 second, half g 1 square. 2 seconds, half g 2 square. 3 seconds, half g 3 square. If we do the ratio, half g common term cancel. 1 square, 2 square, 3 square. Means 1:4:9. So okay, the ratio of distances traveled in 1 second, 2 seconds, 3 seconds. Instead of 1 second, if they ask first second, second second, means that particular 1 second. Third second means second stopped. 1, 2, 3, 4. What is third second? Or 0. 0 to 1, first second. 1 to 2, second second. Third second means ending of 2, starting of 3. This is called third second. If we calculate like that, first second, second second, third second, like that, then the ratio of distances will be 1:3:5:9. Because here Sn means the distance traveled in one particular second. So S1, how much? Z into 1 minus half or G by 2, because 1 minus half means half, G by 2. S2, G into 2 minus 1 by 2 means 3 by 2. So 3G by 2. S3, so G into 3 minus 1 by 2 means G into 2 3 the 6 plus 1, 5 by 2 or 5G by 2. If we do the ratio, G cancel, by 2 by 2 by 2 cancel. What we will be having here? G by 2 is 2. 3G by 2 is 2. 5G by 2. If you do the ratio, G by 2 cancel. Here there is nothing, means 1. So 1:3:5. 1:3:5. Like that. 1:3:5:9 and so on. This is the ratio of distances traveled in successive seconds. Like first second, second second, third second. Or 1 second, 2 seconds, 3 seconds, it is different. 3 seconds means from 0 to 3. Third second means from 2 to 3. Because here if we have 0, 1, sorry. If this is 0, if this is 1, if this is 2, if this is 3, 3 seconds means 0 to 3. Third second means 2 to 3. That particular second. So that's why formulas are different. So in uniform accelerated motion, the distance traveled in every second increases by an amount equal to its magnitude of acceleration. Suppose starting distance 0, after 1 second, distance will be 9.8. After means 0 to 1 second 9.8, 2 seconds 19.6, third second 4 27.4, like that. Means the distance traveled in every second. Here 9.8 increased, 9.8 increased, 9.8 increased. So every second increased by the value of magnitude of acceleration. So for 1 second, 9.8 meters distance will increase. So now equations of motion for vertically projected upwards body. Vertically projected upwards body, for that we are throwing with some velocity. Then only it will go up. You will have some value. But after reaching certain height, its velocity, suppose if it is 40 meters per second, we have thrown it up. But the earth is trying to attract it down. So because of that attraction force, this velocity will decrease. 40 will become 30, will become 20, will become 10, will become 0. Then it starts falling down with increasing velocity from 0 to 10, 20, 30. Again with 40 meter per second velocity, it will hit the ground. With what velocity it went up, with same velocity it will hit the ground. So initial velocity will be 40, but final velocity for upward body, because this is the last step in upward motion, final velocity will become 0. So that's why it is falling down. So for vertically projected bodies, V value is 0. And one more thing, as it is vertically projected, acceleration due to gravity acts downwards. So that's why it is going opposite. That's why it is negative. So that's why it is negative. So A equal to minus Z. So these equations, V equal to U plus AT. So we can substitute 0 in the place of V, or V we can keep like that only. U in the place of A we will keep minus G. V equal to U minus ZT. Here also in the place of A minus Z, S equal to UT minus half GT square. Here also minus 2GS. Here also minus G. That's all. Same equations, but in the place of A we have to keep minus Z. Okay children, that's all for today. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates children. Thank you. Have a good day.